Algebra 2, Chapter 11, Section 1, Introduction to Logarithms. What are logarithms? Logarithms are simply another way of writing or doing exponentiation. They're useful because they allow us to undo exponentiation, which we will see later in this lesson. So, a logarithm, if x is positive, then the logarithm of x, that's what we mean by this statement, is the exponent to raise 10 by, so what we put in here to get x. So the logarithm of x, what the value of this is mathematically, is the number we have to raise 10 by in order to get x. So for example, the logarithm of 100 is 2, because 10 squared is 100, so we write 2 in the exponent of 10 to get 100. The logarithm of 1,000 equals 3, because 10 cubed is 1,000. The logarithm of 10 is 1, because 10 to the first power is 10. The logarithm of 1 is 0, because 10 to the 0th power is 1. The logarithm of 0.1 is negative 1, because 0.1 or 1/10 is 10 to the negative first power. Right, because we inverse the fraction. So in general, we can write the logarithm of x equals y if and only if x equals 10 to the y power. Okay, you can see how these are related with this if and only if. So the logarithm of x, and this is only true when x is greater than 0. So the logarithm of x is y means the same as x is 10 to the y power. This will make more sense as we use this idea. So let's start with some evaluations. The log of the square root of 10. So the log of the square root of 10 is saying what power do I have to raise 10 to get the square root of 10? Well, the square root of 10 can be written as 10 to the 1/2. So this is 1/2. 10 to the 1/2 power is the power we raise 10 by to get the square root of 10. What power do we raise 10 by to get 1 over 100,000? Well, it'll be negative, because we'll end up with flipping the fraction. And count the zeros, this would be squared at 100, cubed, fourth, fifth, so it would be -5. Log of 0.01, by similar logic, would be a negative number. It's 1/100th. 100 is 10 squared, so the answer is -2. Log of 1 over the square root of 1,000 is the same as the square root of 1 over 1,000, so it's the same as the log of 10 to the minus, well, let's think of it this way. It's the same as log of 1 over 1,000 squared root, which is 1/2. Okay, and 1 over 1,000 is 10 to the -3 to the 1/2, so we would have to do the rule exponent to an exponent. This would be, what is the logarithm of 10 to the -3/2? Well, that's just -3/2. What do we have to raise 10 by in order to get 10 to the -3/2? -3/2. And what about logarithm of -10? This is undefined. So if you remember, I said this is only true if x, the thing we're putting in the logarithm, is positive. Otherwise, it's undefined. So let's rewrite the following statements using logarithms instead of exponents. So instead of writing 10 to the 4th equals 10,000, let's write an equation that has to do with logarithms. So we could write this as, what power do we have to get 10 to the 4th? So it would be 4 equals the logarithm of 10,000. Similarly, what do we have to raise? Raise 10 to the negative 3 would be 0.001. So if we write log of 0.001, that would be negative 3, because that's the power we raised 10 to get 0.0001. So basically removing the 10, we're getting rid of the 10 to that and putting log in front of the other side. That's how we write a logarithmic equation that means the same thing. And if I'm going too fast for this, go back and look at this definition. If we have x equals 10 to the y, then we can write logarithm of x equals y. So you see the 10, this kind of 10 goes away here, and we write log here to get from one to the other. Okay, so that's how we can do these kinds of problems. So now, using what we've learned, we can solve this exponential equation. Solve 10 to the t is 4,000. Well, from the definition of the logarithm, we could write that t would be log of 4,000. Because remember, 10 to the x, well, we had written 10 to the y. 10 to the y equals x if and only if y is log x, as long as x is greater than 0. In this case, x is 4,000, so of course it's greater than 0. So we can write t as log of 4,000. And what I didn't mention before is our calculators know how to evaluate this logarithm function. So we can now get a direct answer to exponential equations. And how does the calculator do this, you might want to know? Well, it's really just guessing and checking, just like we did before for exponential equations, but it's doing it very efficiently and very quickly. And so now we can have a way of typing in how to guess and check a solution basically by using a logarithm in the calculator. Logarithm of 4,000 is 3.602 roughly. 3.602 is about t. Now, of course, it's not exact, but this is close enough for what we are doing in this class. Let's now solve this equation. 3 times 10 to the t minus 8 is 13. Well, we can turn this equation into something of the form we just saw by manipulation. So we can add 8 to both sides, divide by 3. And now we have something we can just write. T is log 7. And the log of 7 should be between 1 and 0, since 7 is between 10 and 1. So we can type this into our calculator, log 7.845, roughly. So t is about 0.845. So another way of thinking of the logarithm is that the logarithm undoes raising 10 to a power. So if we think about this, if we have log of 10 to the 5th, we can also write this as log of 100,000, which of course is just 5, because that's the power we raised 10 to get that number. 5 here, what we put in, we get out 5. If we take 10 to the log of 5, we have log of 5. We could find it on our calculator. We could take 10 to the power on our calculator. We'd find that that is 5. Maybe we'll do that real quick. So on a calculator, if we do log 5, we get 0.69897 or so, and then take 10 to that power, and we get back 5. In general, the logarithm undoes exponentiation of 10 to the power. So we get back in what we put out. We get back out what we put in. And the same is true if we take 10 to the power log n, as long as n is greater than 0, because of the logarithm only lets you take in positive numbers. So if we think about the rules of exponents, we had rules like this: 10 to the a times 10 to the b equals 10 to the a plus b. 10 to the a, these common base rules, is 10 to the a minus b. And we also had the power to a power rule. 10 to the a to the b equaled 10 to the a times b. And these have direct extensions to logarithms. Because if these are true, these are also true. Also, we knew 10 to the 0th was 1. So we can write similar properties of logarithms based on these rules of exponents. The logarithm of a times b is the same as the logarithm of a plus the logarithm of b. And this is interesting because the logarithm is turning multiplication into addition. We can also then take the logarithm of a over b and get log of a minus log of b. And the log of b to the t is equal to t times the log of b. That comes from this exponent to an exponent rule. And you can think of this conceptually as pulling the exponent in front of the logarithm inside of the logarithm. And this is a very handy operation because it's turning exponentiation into multiplication, which allows us to solve certain kinds of equations more easily. So also the log of 1 is 0 because 10 to the 0 is 1. So using these properties of logarithms show that the log of 1 over b is equivalent to the negative log of b. So if we think about this, there's the log of 1 over b, using the property that division turns into subtraction, is the same as the log of 1 minus the log of b. And remember, log of 1 we said was 0, so we have 0 minus log of b, which is negative log of b. Also, another way of doing this would be to think that 1 over b is the same as b to the negative first power, and using the exponent to an exponent rule, we can pull the exponent out and get negative log of b. So of course the rules are consistent and work with each other. There's more than one way to get to the answer here. One last thing on our introduction is, remember, the domain of the logarithm function is the log of x. X has to be bigger than 0. Where does this come from? Well, if you remember the exponentials, they had a range of positive numbers. They never touched the axis. They never went under it. The logarithm, since it undoes exponentiation, has a range of all the real numbers, but its domain is such that you can't put in a negative number or 0. Those are undefined operations for our class. So, for the purposes of Algebra 2, if we have a log of 0 that's undefined, and this is generally always undefined because if the log of 0 were defined, division by 0 would be defined as well. And the log of a negative number for this class is also going to be undefined, although you can make a complex number to answer for this, but we're not going to get into that in this class. That would be a topic for much later in math. So for our purposes, we're going to write undefined for a negative logarithm and undefined for a 0 logarithm. So if you ever get in a situation where there's a negative or 0, that's not defined for our class.